Okay, so we're going to start off by making a formula sheet because our notes are probably all in different places. So we're going to put all of our formulas into one place. Now, there's not necessarily 8 formulas, though we're going to make 8 boxes. So you're going to fold your piece of paper into fourths. So obviously taco and then burrito or hamburger and hot dog, how you want to say it. So that we have 4 pieces. And then we're going to use the front and the back side so we have more space. So we're not doing these itty bitty boxes. So in each box, you're going to put a new formula. So it's very important that you draw the picture correctly because based on the picture is how we choose the correct formula when we do these questions. It's really important. So go ahead and take a moment to draw this picture, and then we're going to come back and write the formula. Now, this picture, let's try and recall, has an angle coming from the center. What do we know about the angle and the arc it opens up to? They're the same. So when we have a central angle, specifically see this little dot here, that dot tells us that's the center. We know that this angle is going to equal the measure of this arc, the arc specifically that it opens up to. So again, that's only center. Center, same. Let's do the next one. So go ahead and draw the next picture in the next box. Yes, you got one already drawn here. Go ahead and draw the next one. So this picture is different. Notice here's our center marked, and this is where the angle comes from. Remember, this is what's called an inscribed angle. So what's the relationship here? Look back to your notes if you need to. This relationship is, if it's an inscribed angle, it is 1/2 of the arc. And again, that specifically refers to this angle inscribed. Remember, that means it starts on the circle. This point right here is on the circle versus in the middle, in the center, is going to equal 1/2 of the arc it opens up to. Again, what that also means is the arc is double the angle. It goes both ways, right? We got to be careful there. So notice the difference between these two pictures. Very important, very different relationships. Let's go on to this next one right here. Go ahead and draw that picture. So this one is relatively new, at least we did it last week and haven't had a ton of practice with it. Look back over your notes. What was this relationship? Now this was the fact that this angle right here, and for that matter, this angle on the other side as well, these two angles, notice that they open up to this arc and this arc, right? These angles open up to the top and the bottom arcs. How we get those angles is the angle, this is angle 1, or again, this angle as well, it's going to be found the same way, is 1/2 of both of these arcs added together. So think of, again, you see that X, that means like a plus sign, right? You're going to add the arcs together and divide by 2. I have another picture here. It's going to be a similar relationship, but slightly different. Go ahead and draw the picture in the next box, and then we have all 4 on one side filled out. So this one's slightly different. We're still talking about, excuse me, we're still talking about this angle right here, but it's outside the circle now versus this angle was inside the circle. This one comes outside the circle. This one is similar, but we have that this angle out here is 1/2 still, the outside arc minus the inside arc. So notice again that angle slices 2 arcs there. We need the outside minus the inside. So it's important to know which is considered the outside and which is considered the inside. This is the outside arc because it's out furthest away from the angle, and this is the inside arc closest to the angle. So be careful with that one as well. Because it's subtraction, it matters which is which. Okay, so you should be on the back side now of your paper. You should have all 4 filled in. Go on to the back side of the paper now. So this picture, what we're referring to, the questions are going to be asked when you have this picture here, is if something is a tangent. So specifically, if this line is a tangent on the outside. Because remember, a tangent touches at one point. How we prove it is by doing Pythagorean theorem. If a squared plus b squared equals c squared. Now, keep in mind, this ABC does not refer to this ABC. Remember that C has to be the largest side. You're going to be given these three numbers. C has to be the largest side. A and B are just the other two sides. And then we see if this is a true statement. If we do not end up with the same thing on both sides of that equal sign, we would say no. We can't just say no. We're like, yeah, sure, it looks like it. We have to check doing Pythagorean theorem. And we'll try a problem with that later. It's been a while since we had to do that. So equation of a circle. So we just did this on Friday as well. So you should have it in your notes. The equation of a circle is this: x minus h squared plus y minus k squared equals r squared. We want to write down as well that hk tells us the center of the circle. Remember, whatever I see in the equation, h and k are going to be opposite of that. We'll look at that later. And r is the radius. Again, we have r squared here. Remember, to get just r, we take the square root, right? Square root is the opposite of a square. Okay, so for these last two, we're just going to put some facts. So circle facts. This is in your last bottom two boxes you have there. So in that one box, let's put some facts. A circle has how many degrees? 360. That's very important to remember for some of these questions. A whole circle is 360 degrees. That's a full turn. Now, if we have a diameter in a circle, remember that a diameter cuts a circle in half, right? That creates a semicircle, which is just a half of a circle, right? My hand right here would be like a half of a circle. This is a whole circle. So the diameter creates a semicircle, which has how many degrees? Well, if it's a half of a circle, it has 180 degrees. So again, whole circle 360, a diameter cuts a circle in half, creating 180 degrees. Now, this last one we haven't talked about in a while, but what's the relationship between the radius and the diameter? The radius is just to the center of the circle, and the diameter is all the way across. The radius is half of the diameter. And again, that means that the diameter is double the radius. Try and keep that straight, which way that relationship works. Now, again, you're going to have some questions in the test that are just about vocab. So if you want to look over your notes, you have one more box there. If you'd like to put any other vocab, like chord or secant or tangent, whatever, arc, minor arc, major arc, yeah? You can put that in that box there, and then you have one thing all ready to go for your test to make your life easier. Now, from here, I'm going to go through a couple questions. The key part to this test, guys, is being able to identify the formula based on the picture. It's hard. I know sometimes we have a hard time focusing. Really try to use your formula sheet and identify the correct formula, and then we have to use it correctly from there. But if we can at least get the formula, that's half the battle. So I have them kind of jumbled up. They're not in the order of the formulas. So you're going to have to look at a question, look to your formula sheet, and figure out what we're going to be doing. This first one should be pretty simple, though, because this is the equation of a circle. So we know immediately what we're looking at on our formula sheet here. Now it says, what is the center and radius? We want, as our answers, HK, and we want R. So take a moment, see if you can remember how to do this. For each of these questions, I'm going to go through them kind of quickly. I'm going to give you a chance to try, and then I will do it and explain. So go ahead and find what's the HK and what's the R. Okay, so I'm always going to copy my formula underneath so that I know what lines up with what. I want just H and K to start with. So H is here. I see it as a -5. I pull it out as the opposite. Again, that's because the formula has x minus. So H is just 5, not -5, right? I pull it out as the opposite. Now, Y is by itself here. Y has nothing with it. And what's nothing as a number? 0. So remember, if you have Y or X by itself, that H or K is going to be 0. So there's our center. Now again, for R is what we want, the radius of the circle. But this is R squared. So you should have done the square root of 60 is R. And again, that's because a square root undoes a square. So you can plug that in your calculator. They probably want it as a decimal in your test if it doesn't work out evenly. So let's check. So in my calculator, this says 7.7. So that might be what you plug into the test, or they might have it as a multiple choice and then just leave it as a radical. That's an option too. So these are our two answers, 5, 0 and 7.7. There's my center of my circle if I were to graph it, and the radius. Okay, let's try the next one. So I want you to look at your formula sheet, look at the question being asked, and see what we're going to do here. Okay, so this is, if we have a tangent line, we need to see if a squared plus b squared equals c squared. If this is not true, meaning we say no, right? So let's go ahead and test this out. I'm going to go ahead and put c squared over here because we're kind of used to looking at it that way. Hopefully we're used to it. And a squared plus b squared over here. What is my c value? We have 3, 4, and 5. Which one has to be c? 5 has to be c because it's the biggest side. Now remember, it needs to be 5 squared. It's c squared, and c is just the 5. So this is going to be a and b. Doesn't matter which is which. Remember, a and b can kind of get moved around. It's just the c that has to be particular. So let's go ahead and use a calculator, take a moment, and see what do we get on both sides of this table. Are they the same thing? If so, we say yes, it's a tangent line. If not the same thing, then we say no. Okay, so this is 25. That's 5 times 5. This is 9 plus 16. That actually equals 25 as well. So what this means is we get to see, yes, AB is a tangent line because this is true. If we ended up with different things on both sides, so like 26 and 24, we would say no. So we have to check. You can't just look at something and go, yeah, sure. You have to double check. Okay, same thing here. Look at the picture. Notice this is the center. If there's a dot given to us, that's the center versus like just lines connecting. That's the center of the circle. So what situation are we dealing with here? This is a central angle. This is the angle is going to equal the arc. But guys, with this one, you got to be very careful. Notice what we're given. We are given BAC is 92. We need to focus on what we're trying to find, and we are trying to find arc B to D to C. That's this. So this is not a true statement here, where this angle equals this arc. Remember, the angle opens up to the arc it's equal to. If I cut this slice of pizza out, this angle equals the crust that I've cut out. So we do know that. We do know that this piece will be 92. That is actually going to help us find what we actually want to find. If this piece is 92, because the angle equals the arc that it opens up to, and this is the rest of the circle, how do I find the rest of the circle? How many degrees are a full circle? Well, the full circle is 360, and we already have 92 degrees. So this is going to give me what I actually want. Again, guys, sometimes we focus so much on what's easiest, and we don't think about what the question is actually asking us. The question did not ask us for arc BC. It asked for arc B to D to C. So we have to focus very carefully on those letters they give us. That tells us what we're looking for. Okay, once again, got to be very careful here. We have a cross. They're crossing inside the circle. Keep in mind that they did not tell us they're crossing at the center. They would give us a dot or like a letter right where they're crossing if we knew this to be the center. So this is not crossing at the center, so this is a different relationship. What is it? So this is the angle equals 1/2 the arc plus the arc. But again, we have to be very careful to know what arcs they're talking about. This angle is equaling the arc it opens up to plus the opposite arc. Notice those are across from each other. And then we take half. So this one's actually easy. I'm trying to find the measure of angle 1. I have 1/2. I have the two arcs it's opening up to. So 60 plus 31. That's not too bad. This one we can just plug straight in. We have to keep in mind that sometimes it's not that easy. Okay, so this is 45.5 because it's half of an odd number. So that's going to be our answer. And again, that's because we were looking for the angle and we knew both of the arcs. Be very careful where stuff gets plugged in. If we knew the angle, it would get plugged in over here, right? Be very careful. Okay, next picture here. We just got two more situations. What does this one look like? What's the relationship? Before we even look at what this question is asking, look at the picture. What formula are we using for this picture? This is the one sort of similar where the angle, in the case of the picture that I gave you, I called it angle 1. Here it's referring to this angle, equals 1/2. We have the outside arc minus the inside arc. I just like to say outside minus inside. So this is a situation where we have to be very careful what we have. Notice this is the angle. This is the outside arc. And what we don't know, what we're trying to find, is the inside arc. So I want you to take a moment. Where we plug in our stuff then is going to change kind of how we did the last question. So go ahead and try to plug in the information here and then we'll check. So we know our angle is 15. That's where the angle goes. I don't just get to plug in numbers wherever I want, right? This is the angle. It goes in place of the angle. Then we have 1/2. The outside is 100. And we are trying to find the inside. So I'm going to leave it like that. So this is what I was showing you guys in class. There's different ways you can do this, guys. If you hate fractions, I'd recommend maybe you just change this to 0.5. Sometimes we like working with decimals more, which is kind of weird. However, I'm going to get rid of this 1/2. This is a trickier question we haven't had a lot of practice with. This is 1/2 times what's in parentheses, right? Now I could go ahead and distribute out that 1/2 because again, that's parentheses, we would distribute. Or I can get rid of it right away without having to distribute it. This is 1/2 of this, right? In order to get rid of it, we know we need to do the opposite, right? What's the opposite of taking half of something? Doubling. So if I double this, if I multiply by 2, that's going to cancel that out. I just have to be careful that whatever I do to one side, I have to do to the other. Again, there are other ways to solve this equation. I like to get rid of the half right off the bat because it saves me a step. If I distribute, I'm doing an extra step. So again, the opposite of taking a half is doubling something. So that cancels it out because I did the opposite. Over here, I'm going to have to double this. Whatever we do to one side, we got to do the other. And then we have 100 minus the inside arc. That's all that's left. Go ahead and keep solving this equation. Okay, so we're going to minus the 100. Now, this is going to give us a negative, but that's okay. This will be negative 70 equals, what we have left over here is negative the inside arc, right? So I can actually just cancel out this negative on both sides. Really what I'm doing is dividing by a negative on both sides, but I'm good. The inside arc that I was trying to find, now again, that's arc BC. That's what I was trying to find, equals 70 degrees. It's okay that we had that negative there because again, these negatives end up canceling out on both sides. So be very careful. Sometimes it's not just a straight plug in the two things, boom, spit out your answer. You might have to move some stuff around. You have to be aware of that. Okay, last one here is an example. We got a picture. What is the relationship? Before we even look at what it's asking, what's the relationship? This is an inscribed angle. So this is the fact that the inscribed angle equals half the arc. Now, with this situation, again, this angle is 1/2 of the arc. With this situations, I wanted you to remember that The angle is the small one, and it opens up to a great big arc. That helps us figure out what we're trying to find here. So we have angle DCE is 20. It's important to know that we have the angle. We want to know the arc that it opens up to. So yes, the angle is 1/2 of the arc, but we know the angle. So sort of using this fact, but again, our angle is small and our arc is big. Am I going to take half here, or am I going to double to get to my arc? We're going to double it. Again, this is like saying 20, which is our angle, equals half of the arc. We know how to do this because we just did it. If I multiply by 2, that's going to cancel out the 1/2. So you can use the formula, or you can use the fact that if we know the angle, we're going to multiply by 2. If we know the arc, we're going to divide by 2. Just keep in mind that the angle should be smaller than the big arc that it opens up to. That helps us know if we should multiply or divide. And then one more note here to wrap this video up. Remember that this relationship only applies to this picture. This is a different picture with a different relationship. We tend to get these two mixed up. I cannot make it any clearer to you that these angles are drawn differently, not the same relationship. Okay, so hopefully that helps. I just wanted to give one example of each formula, but there's lots of different variations. You guys really need to complete the review to see all these different kinds of variations on these formulas.